lecture for CS8591 computer networks, unit 3 network layer. This is the second video for unit. So the problem is, if an IPv4 packet, the value of h length is 5, the value of total length field is 0028 to the base 16, it is a hexadecimal number. How many bytes of data are being carried out by this packet? The h length is 5, the value of h length is 5, which means that the total number of bytes in the header is 5 into 4 is 20 bytes, no options, right? The total length is 0028 hexadecimal number, which is equal to 40 bytes, which means that the packet is carrying 20 bytes of data and 20 bytes of header. Then the next problem, a packet has arrived with an m bit value of 0. Is this the first fragment, last fragment or middle fragment? Do we know if the packet was fragmented? The solution is, if m bit is 0, it means that there are no more fragments. The fragment is the last one. However, we cannot say if the original packet was fragmented or not, but the non-fragmented packet is considered as a last fragment. So, if the m bit is 0, which means that this is the last fragment. The next, a packet has arrived with an m bit value of 1. Is this the first fragment, last fragment or middle fragment? Do we know if the packet was fragmented? That is, the solution is, if the m bit is 1, this means that there is at least one more fragment. It is not the last fragment. This fragment can be first one or a middle one, but not the last one. So we don't know if it is the first one or middle one. So we need more information to find out the first one or middle one, the value of the fragment offset. The next problem, a packet has arrived with an m bit value of 1 and a fragmentation offset value is 0. Now they have given the offset value. Is this the first fragment, last fragment or a middle fragment? The solution is, we know that because the m bit is 1, it may be either the first fragment or the middle one, right? Because the offset value is 0, what it means? It is the first fragment, no offset value. Is it clear? The next, a packet has arrived in which the offset value is 100. 100 is 4, right? What is the number of first byte? What is the number of first byte? Do we know the number of last byte, right? The solution is, to find the number of first byte, we multiply the offset value by 8. This means that 100 into 8, that is 800. The first byte number is 800. We cannot determine the number of last byte unless we know the length of the data. They have given only the offset value and they have asked for the number of bytes. So, since the value is 100 and we are multiplying it by 800. The next problem, a packet has arrived in which the offset value is 100. Now they have given the length, right? Header length. The value of the header length is 5. The value of the total length field is 100. So what are the numbers of first byte and last byte? So now we can calculate the first and last byte. As usual, what is the first byte number? The number is 100 and it is multiplied by 8, that is 800. 800 is the first byte number. So the total length of the field is given as 100 bytes and the header length is 20 bytes. 5 into 4, it is 20 bytes, which means that there are 80 bytes in this datagram, right? The first byte number is 800 and the last byte number is 879. Is it clear? We will go to the next problem. IP address 232.43.14.7 to an Ethernet multicast physical address. So, we can do this in two steps. First step is, we can write the rightmost 23 bits of the IP address in hexadecimal. This can be done by changing the rightmost 3 bytes to hexadecimal, then subtracting 8 from the leftmost digit if it is greater than or equal to 8. In our example, the result is 2b.0e.07, right? Then we can add the result of the part A, that is this answer, to the starting Ethernet multicast address. So that's which is 010050000000. So we can add this and we will get the result 01/01005E2B, then semicolon 0E and 07. So this is the Ethernet multicast physical address. Now let us see the last problem. Change the multicast IP address 238.212.24.9 to an Ethernet multicast address. As usual, the rightmost 3 bytes in the hexadecimal number are D4.18.09. We need to subtract 8 from the leftmost digit. So we can subtract 8. So we will get 54.18.09. So we can add the result of this part A to the Ethernet multicast address. So 01 semicolon 00 semicolon 5E semicolon 54 semicolon 18 semicolon 09. So this is the Ethernet multicast address. Thank you.